Hello, good evening, Swati. We'll wait 2 more minutes for others to come and then we'll start. So, yeah, good evening, everyone. Welcome back. If you remember not yesterday, exactly, Friday's class or little last lecture, we stopped at equation of a line. So, we stopped at equation of a line. We are doing which chapter? 3D line. So I know we did 2-3 minutes of introduction here, but let us again revise it and then proceed the class. So here, equation of a line. So everything now, equation of line and equation of plane. Next topic is, so in both the cases, we have equation. First, we'll do equation of line, then we'll do equation of plane. Now, let me tell you, since we are in 3 dimensions, both equation of line and equation of plane will be in two types. First type will be vector form, and second will be Cartesian form. So let's see how the vector form of equation of line looks like. So vector equation of line is given by one sec, yeah, R vector is equals to A vector plus T times B vector, where T is basically a constant. T is basically a constant. My voice and videos are clear. Then we'll move further, guys. All good? Okay. Yeah. Chalo. So R vector equals to A vector plus TB vector. Now, let me tell you what is A vector. A vector is the point which lies on the line, and B vector is a vector along the line. Vector along the line. So suppose let's say this is my line and this is my point A, which is A vector. Then the vector along the line is B vector. So very simple example. Very simple example we'll do here. Screen is blur. Why is it blur? Now is it clear? Still not clear? Okay, 1 second. Give me a second. Now is it clear? I think now it should be proper, right? Hello? All good? Why? Why? What's happening? Why the screen is not clear? Yeah, the one that joined now, is your screen clear? It's clear. It's clear. I checked from my phone. In my phone it is clear. Beta. I checked from my phone also, and what I think issue is something with. Please leave and join again. Try that. All good now. So I think do one thing. You can leave and rejoin. Try that. Because I checked with another sir also. Is it fine now? Yes. Is it yes? Okay. Chalo. So let's see vector equation of line. Here, this is the point. Now I can write this point in vector form as that means in terms of I, j, and k. So what will just substitute the value? This is a vector, and this is the b vector. So my answer will be r vector is equals to 2i cap vector form plus 3j cap minus k cap plus t times what is b vector? Parallel to the vector, which is I cap minus 2j cap plus 3k cap. So I think till here we did in the last lecture, but still it is better to revise and then move forward. Let's see what we have next. This is a Cartesian equation. Yeah. So Cartesian equation is basically equation in terms of coordinates, that means in terms of x and y. Now, in case of line, this equation is also called symmetric equation. So, what is symmetric equation here? The point on the line is x1, y1, z1. Remember one thing, to find equation of a line, we need two things. First of this is point on the line, and second is vector along the line. So here, as we cannot use the vector, that is I, j, and k in symmetric form, we use the DRS, that is direction ratios. So this LMN are the direction ratios of the vector which is along the line. And this is the point. So the equation can be written as x minus x1 upon L is equals to y minus y1 upon m is equal to z minus z1 upon n, where t is a scalar. What is t, guys? T is a scalar. As I told you, this is called Cartesian form, or for line, it is also called symmetric form. If you try to recall, it is similar to parametric form we did in 2D line. Let's see what we have next. This is the same thing we did. Let's find the Cartesian equation in this case. So, the equation of the line passing through point this. So, this is basically point, that means x1, y1, z1, and this is a vector. So, if this is a vector, what are the DRS, guys? 6, 3, and minus 2 are the DRS. We just need the coefficients. Why? Because we have symmetric form, no need for ijk or a vector. So the equation will be x minus x1 upon DRS 6 is equals to y minus 3 upon 3 is equals to z plus 4. Please remember here, z minus of minus 4, that will be z plus 4 upon minus 2. This is my equation. There is no need to write t always. We can leave the equation here itself. Let's see what we have next. Now, this is something you need to remember. Why? Because let me tell you, we need two things, point and vector along the line. So here, let me say, okay, let's look at the example first. Yeah. We'll never use this form because let's get this equation by using a normal concept, that is point and DRS. Let's say this is the line, and here we have 2 points A and B on it, as it is given in the question. Find the vector equation of line passing through 2 points. One of the point is 1, 3, and 4, and other B is 3, minus 2, and 2. So, what I need point. We have 2 points. That is point we have. I need direction or vector along the line. Now, to get the vector along the line, it will be AB vector, right now, guys? We can get the vector along this line, which is AB vector. What is AB vector? AB is B minus A. So let us subtract this. I hope you know the subtraction. Corresponding numbers ko will subtract. So it is 3 minus 1, 2i, minus 2 minus 3, minus 5j, 2 minus 4, minus 2k. So this is basically vector along the line. And whichever point you want to take, this is the, let's say I take this point. This is the point. So if you remember, let me write the equation in a more generalized way, which is r vector is equals to point plus p times drs. Please remember this is a vector form. So point and drs must be in terms of I, j and k. So here this is the more generalized form. R equals to point plus t into dr. So here my answer will be, guys, r vector is equals to point. This is the point. So I plus 3j plus 4k plus t times drs. This is the drs. Drs are 2 minus 5 minus 2, but we need a vector. So that means 2i minus 5j minus 2k. This is my answer. See how simple it is? So no need to remember such extra formulae, just need to remember two forms. One is a vector form. R vector is equals to point plus t into drs. Let's see the next. Now this is the same question, but it is in Cartesian form, right? So same thing. These are the 2 points which are minus 2, 3, and 5. And this is 1, 2, and 3. Right, guys? So same diagram we'll draw. This is the line. This is point A. This is point B. What will be vector along the line? It will be AB vector. So what will be AB vector, guys? Just subtract. AB vector is B vector minus A vector. So 1 minus of minus 2, 3. Then 2 minus 3, minus 1. 3 minus 5, minus 2. So this is the basically DRS, and point we can use any because both the points are on the line. So my Cartesian equation will be x minus x1. Let's say I use this point. Oh, this is looks better. So x minus 1 upon DRS, which is 3, is equals to y minus 2 upon DRS, which is minus 1, is equals to z minus 3 upon DRS, which is minus 2. This is my answer. Got it? Clear till here? Give me a thumbs up if it's clear, guys. All good? Yes or no? All good, guys? Okay, super. Let's see the next question. Yeah, now we are doing questions. Oh, sorry. Yeah. So I'll give you a minute to try. Come on. The time starts now. Let's see. These are very simple questions. we have to find vector equation. If you remember, the vector equation is r vector is equals to a vector or point plus t into drs. Point plus t into drs. So what are the DRS here? This is the DRS. Since we want vector form, and this is the point, so r vector is equals to point plus t DRS. So I can write it as r vector is equals to point is 2i plus 3j plus k. Obviously, there is cap here everywhere plus t. DRS we have to write in vector form. So 4i minus 2j plus 3k. This is my answer. Parallel to the vector, guys. Parallel to the vector and along the vector means the same. A line is parallel to a vector or a line is along the vector. That both the cases means same. Yeah. I think I explained how to do this question. So I'll not be doing it, but you can do it and I'll give you 1 minute is enough. So let's give you 1 minute. This question is for you to solve. And if you got an answer, please say yes or no. Then we can move to the next. Come on, let's see. 2 points are given. Let's say one of the point is A, one of the point is B. Got it? Superb. Let's move to the next question. Yeah, sorry. This is the good question. Let's see. Let us first try to understand the question, what it is trying to say. So, yeah, let me move aside. Here it is given OABC is a parallelogram where OA vector is equals to A vector. So this clearly means O is origin and the position vector of point A is A vector. And same with point C. Then equation of side BC. We have to find equation of side BC. Now, let me tell you, no worries. Or every time we have to find equation, we look for two things. First is point. Second is the DRS, which means vector along the line. So, here, can we see any point which is given? Yes, this is the point. What is DRS? DRS means any vector parallel to BC. Now, as you can see, OA vector or AO vector, you can take any OA vector or AO vector is parallel to BC. That means this is my DRS. So we got the point. This is the point. This is the DRS. So what is the equation of BC? Do you remember R vector is equals to point plus T times DRS. So here R vector will be equals to point is C vector plus T times A vector. This is my answer. So simple. But it just look for point and then look for DRS. Clear, guys? Let's see the next question. Yeah, it's again a good question. Let me give you some time to think about it. Actually, I also drew the diagram for your reference. I should have not drawn it, right? Let's draw the diagram. So I hope you have read the question. Now, let me explain the question. So basically, let me tell you what is the question. Question is, this is a given triangle which is A, B and C, where AD is a median. So if AD is a median, that means D is the midpoint of BC. And if D is the midpoint of BC, then I can easily get the coordinates of D, which is B vector plus C vector upon 2. What are the coordinates of D? B vector plus C vector upon 2. So, and they are telling us to find equation of AD. So again, to find equation of AD, we need only two things. One of them is point and second is DRS. So let me draw separately the line AD or the segment AD, where this is point A, this is point D. So what is the position vector of A? Is A vector, D is B vector plus C vector upon 2. So as you can see, we have 2 points. So this is as good as we have done this so many times, I think, right? So let's say this is A vector. So what will be my vector along the line? It will be AD vector. And AD vector means D vector minus A vector, which is B plus C by 2 minus A, which is B vector plus C vector minus 2A vector upon 2. This is my DRS. And we can take any point. Let's say I take this. So what was the equation, guys? R vector equals to point plus T into DRS. What is the point, guys? It is I took A vector as a point. So A vector plus T times what is DRS? B vector plus C vector minus 2A vector upon 2. So this is my answer. Right, guys? Chalo. Now, I think you may not find this answer in the option. Let me tell you why. Because I can write it as T upon 2. And T upon 2 now becomes another constant. Let's say lambda. B vector plus C vector minus 2A vector. So you may find this answer and you may not find this answer if options are provided, because this 2 can be written as lambda with T. So you might see this answer instead of the above answer. Got it, guys? Let's see the next question. Okay. This is a nice question. So I'll give you 2 minutes to think. Please think. Let's give you 2 minutes. I think you can find the equation of line pretty easily. Other thing you need to find is the position vector of P. So that is a good question. Let's see. Give me just equation of line and I'll help you to find the position vector. Just tell me the equation of line, guys. What the equation of line? I think it's pretty easy because the line is parallel to this. That means this is the DRS and this is the point. So the equation will be r vector is equals to point 3i plus j minus k plus t times DRS 2i minus j plus 2k. Right. So I got the equation. Now here is the important thing. Right, don't worry. For this, let me tell you, we'll use the symmetric form or the Cartesian form. So the Cartesian form will be x minus point is here. So 3 upon DRS is here is equals to y minus 1 upon minus 1 is equals to z plus 1 upon 2. This is equal to t, right? So if I equate this with t, this with t, and this with t, what I'll get is I'll get x coordinate 2t plus 3. I'll get y coordinate minus t plus 1. And I'll get z coordinate, which is 2t minus 1. So let me tell you, if you remember the parametric form of equation of line in straight line last year, I think you don't remember, but still, you must remember something like parametric form suna to hoga na? So in that, we use this. What is meant by this? Let me tell you, these are coordinates x, y, and z, but they are coordinates of any random point which lies on this straight line. A, A, sorry, first point. These are the coordinates of any point which lie on this straight line. Second, we want the point on this straight line which is a distance of 15, which is at a distance of 15. So this is our condition. So that is AP is equals to 50. So I can say AP square is equals to 225. What is A? Here is the point A. Here is the point P. Let me write point A. 3, 1, minus 1. So I can use Aram se distance formula. Let's use distance formula here. Oh, I'll move this side. Yes. I hope you can see the board, right? Chalo. AP square. X2 minus x1, the whole square. So I get 2t plus 3 minus 3, the whole plus y2 minus y1, the whole square, minus t plus 1 minus 1, the whole square, plus z2 minus z1, the whole square. That means 2t minus 1 plus 1, the whole is equals to 225. I think this all will get cancelled. I'll get 2t square, which is 4 plus t square plus 4t square is equals to 225. So 4 plus 4, 8 plus 1, 9. So 9t square is equals to 225. Let me move this side now. I think t is 15 upon 3. Once I got the t, I'll get the point. What is the point? This is the point. Let's substitute the value of t here. Let me tell you, we'll get 2 points because we took under root. That means plus and minus. Why we got 2 points? Simple thing. If this is point A, then at a distance of 15 units, there will be 2 points present on the same line. One on the right side and one on the left side. That's why we got 2 points, 2 values of lambda. Let us substitute one value. I'll substitute the positive one. You can check the negative. So if I substitute 15 by 3, so 30. Oh, I think 15 by 3 is 5. Plus minus 5, right? What are we doing? So plus 5. So I'll get x as 5 to the 10 plus 3, 30. Y as minus 5 plus 1, minus 4. And z as 5 to the 10 minus 1, 9. So my point is 13, comma minus 4, comma 9. And same for if we substitute minus. Minus and I'm not doing, please try yourself. Yes. Oh, sorry. This is a good question. Now this is something which we did. It is just reverse. कुछ active passive होता है ना, active voice passive. Just that way they have been asked reversely. Let's see who can do it. Got it, guys? What you can do here? You have to find a point on the line. So I think to find a point, you just need to substitute the values of t. Correct? So let's say if I substitute t equals to 2. So for t equals to 2. Why I substitute t equals to 2? Because everywhere I am saying 5i. 5i, 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 5. That means if I substitute t equals to 2, this will be 4i plus 1i, 5i. So that's the logic I use by substituting t equals to 2. Got it? So this will be, sorry, the point will be, I substitute 2 equals to 2, na? So 2 to the 4 plus 1, 5i minus 2 plus 2 plus 0j, 6 minus 1. So plus 5k. This is my answer. Option number 2. Right, guys? Now, next thing is skew lines. What are skew lines, guys? Skew lines are nothing but the lines which are non-coplanar. lines that are non-coplanar. So if two lines are non-coplanar, yes, it is possible that two lines can be non-coplanar. They are called skew lines. So if question, how the question comes? Question is will come as we have to find the distance between those skew lines. So it is better that I explain how to find the distance by using the question itself. It will be way better for you all to understand. Let's see. So let's see the question. Yeah, this is the question. Find the shortest distance between the lines. So let's say these are two lines. One is in this plane, other is in this plane. So these are two lines, right? Here, let's say this is point A. This is vector M1 or M1 DRS. This is point B. This is M2 DRS. So the shortest distance will be the perpendicular distance between two. This perpendicular to this. I hope you can imagine it in 3D, right? These are two planes. Any two planes you can take, and this is the shortest distance. So this will be M1 vector. This will be M2 vector. Now, if I take M1 vector cross M2 vector, then I'll get the vector which is perpendicular to both, right? And let's say this is point A, this is point B. If I join point A and point B and I draw a torch here. So here you can see the shortest distance D is basically projection. Projection means shadow. If I on the light from here, that means the shadow of AB. So projection of AB on M1 cross M2. I hope you can imagine it. Iska shadow M1 cross M2. It will give me on M1 cross M2. It will give me the shortest distance D. I hope it is clear. Iska shadow on the M1 cross M2. So if I take a shadow of this on M1 cross M2, it will be the shortest distance which is required. So let us find AB vector. AB vector is B minus A. This is B, this is A. So minus 10, comma, minus 2, comma, minus 3. Let us find M1 cross M2. M1 cross M2, how will we get? By using cross product. IJK 1 minus 2, 2. 3 minus 2 minus. So 4 plus 4, 8. Minus 2 minus 6 plus 8, J. Minus 2 plus 6 plus 4K. So what is projection? Projection is AB dot M1 cross M2 upon magnitude of M1 cross M2. What is the magnitude of M1 cross M2? Under root of 64 plus 64 plus 16, which is 10, 14. So 14, we have 1 carry, 6 plus 6, 12 plus 1, 13, 144, which is 12. And we have to take dot product of AB and this. If I take dot product, I'll get, obviously we use modulus. Why modulus, guys? Because it is distance and distance is positive. So minus 80 multiply this. I hope you know how to use dot product. Minus 16 minus 12. upon 12. So modulus say minus will get gayab, right? So 96, 106, 108 upon 12, which is 9. So the shortest distance between the skew lines is basically the perpendicular distance between two lines, which here in this case came 9. Always remember how to find shortest distance, guys. First, get M1 cross M2. Second, get AB. And third, take projection of AB on M1 cross M2. Again, first, get AB. Second, get M1 cross M2. Third, take projection of AB on M1 cross M2. So here we have completed with lines, and I hope you know the reduced syllabus. The many of the questions in planes are cancelled. Most of the plane is cancelled. We only have equation of plane in vector form and in Cartesian form, right? So we'll meet in the next lecture with plane. Next lecture is tomorrow. Till then, bye bye everyone. Take care. Tata. Bye guys.